So now let's have a closer look at the testing requirements for wireless devices from the different areas R&D up to conformance testing, and also what kind of approaches are available, also what are the LTE specific things we need to consider. This slide illustrates the different stages of the LTE terminal or wireless device testing, and to also illustrate some of the terminology used. So R&D testing on the left hand side, that is focused typically on the verification of basic functionalities and also of the performance of the first terminal or chipset implementations. So this can of course focus on the different technical areas like RF, layer 1 physical layer, protocol stack, also application level investigations. Then the stage of IoT interoperability testing, that is used to verify the interaction between a terminal and between a real network, but also the interoperability between different LTE features, and of course also between LTE and other radio technologies can be verified. So this is also really closely linked to first field trial activities to, for example, do the network simulation in the IoT and then go to the real network in the field trial and verify whether the terminal can cope with that. End-to-end testing is another important requirement in this stage. Conformance testing is verifying the standard compliance of an implementation. That means the compliance to 3GPP standard or other standards implemented. It is the basis for the terminal certification process as well, which is a very important process. It can be considered a quality gateway for the terminals. Production testing focuses on the final functional test and on alignment procedures. And then maintenance and service applications for terminals typically address basic functions and parameter test. So in the following we will have a bit closer look on the IoT and the conformance testing and also on the field trial test requirements, especially for LTE. So the LTE terminal interoperability testing, let's have a closer look at that and the associated requirements. So interoperability testing is used to verify the connectivity of the UE with the real network, typically by means of base station simulators, system simulators. So service quality, end-to-end performance are very important things to verify at this stage. Different LTE features and parameterization can be checked, and also interworking between LTE and legacy technologies. So at this stage the complete UE protocol stack is tested, and the requirements are typically based on the requirements from real network operation, so to simulate real network scenarios and typical use cases. Let's have a look at some example test scenarios for IoT. Could be basic procedures like registration, UE-initiated detach, network-initiated detach, EPS bearer establishment, mobile originated or terminated, cell reselection, reallocation procedures, for example, of identities like the GUTI, tracking area update, plus end-to-end scenarios with video streaming voice over IP, plus mobility scenarios inside the LTE or also including inter-RUT cases 2G, 3G as well. Now, who's typically providing requirements for these IoT test scenarios? For example, standardization fora like 3GPP focus more on the conformance test rather than on the IoT. So what are the sources for these test scenarios? There are different sources available. Some examples are given here. Of course, the test scenarios are provided with the system simulator. So Rohde and Schwarz is providing some test scenario packages for basic procedures, BIRA verification, etc. Also on top of the system simulator, the base station simulator. Network operators have additional, very specific requirements for their network, which are often also used for terminal acceptance to the network. Furthermore, another important example, the LSTI forum is providing test recommendations for IoT as well. So LSTI is the LTE SAE trial initiative. Compared to the IoT interoperability testing, the focus of conformance testing is a different one. It is used to verify compliance of terminals to 3GPP standard, to the LTE standard. So for conformance testing, validated test cases are implemented on registered test platforms and they are used to do the conformance testing. And the major goal here is really to ensure worldwide interoperability of the terminal within every mobile network worldwide. The conformance tests are defined in 3GPP in the Radio Access Network Group 5, RAN 5. And RAN 5 defines conformance test specifications for RF, for radio resource management, RRM, and for signaling. These conformance tests are then taken to certification organizations, for example GCF, which then define certification criteria based on the RAN 5 test specifications. What is really the benefit of terminal certification and what are the success factors for that? So terminal certification is an important process because it is really important for the successful commercialization of new handset types. You can see it as a quality gateway to ensure that global interoperability of terminals can work and to also increase the reliability and performance of the terminals. It works as a partnership between network operators, device manufacturers and the test industry. So some certification fora and groups are shown here. And it is important that they have a close liaison between the standardization fora and the certification group, so that there's a close interaction between the people who write the test specifications and then those who use them for certification. For LTE, there's already very harmonized processes established. So for LTE, FDD and TDD, there's work items already defined and a certain structure how to proceed with the certification process for LTE. So this section now addresses LTE field trial testing and coverage measurements. The first LTE field trials have already started, so LTE commercial network deployment is about to start. And so this is really an especially interesting area to really see what are the requirements coming from specifically from LTE for the real trials. So first of all, there's a lot of different deployment scenarios for LTE. So we have seen that there's the bandwidth scenarios. You have small bandwidths from 1.4 MHz up to the 20 MHz. So depending on the network operator and the spectrum availability, different bandwidth scenarios will be required. Also there's FDD and TDD. And there's different frequency bands, of course. So depending again on network operator decision and regional requirements, FDD or TDD and different frequency bands will be used. The combination with legacy technologies is a very important area for testing here. So you have interworking with GSM Edge, wideband CDMA, HSPA, CDMA 2000, EVDO, depending on the installed base at the network operator. So spectrum clearance and refarming scenarios have become very important for LTE as well. So you need to make sure before you start and deploy the LTE, what is the situation in that spectrum? Is it really available for LTE already? What are the interference situations there? In future also we will see more femtocell scenarios in LTE, that's the home eNode B, home base station. These will be deployed in a large scale, so also from that we would expect more requirements for trials and LTE specific requirements for the home eNode B. What is the scope of the test tools for field trials? The field trials provide input for the calibration and verification of the planning tools that are used by the network operator for all the different deployment scenarios. They provide input for network optimization in terms of capacity and quality of service verification, especially from the point of view of the subscriber, definition of KPIs, key performance indicators, and verification of them. Again, also from subscriber's point of view, where really the subscriber is in the network to verify what kind of experience is he seeing. As measurement tools, parallel use of scanners, measurement receivers for comparison with the terminal and the base station behavior is recommended. And these input can then be very well used to support IoT activities again, to also compare with the network and the terminal behavior. Some example measurements, some example result from the field is shown here, a scanner measurement for LTE. So the upper part of the figure shows actually pilot measurements on different cells in LTE based on different cell IDs. So you can actually see here the top N list of the pilots that were detected. That can be on different frequencies. And the lower figure here shows the channel impulse response that was recorded. That is actually a very interesting measurement, also allowing for LTE, for example, special investigations. We have seen that different cyclic prefix configurations are possible for LTE, so a longer one, a normal one. So with this measurement you can now evaluate actually the delay spread of the radio channel and whether the cyclic prefix configuration is the right one, whether it's large enough to combat the inter-symbol interference and to avoid then performance degradations in the network. So this actually concludes the LTE tutorial today. So in case you would really like to know more, to read more, please have a look at the LTE application notes from Rohde and Schwarz on the website on the download area. Some are listed here. Technology introduction for LTE is available, as well as RF chipset verification for UMTS and base station testing according to 3GPP specs.